The solar eclipse is it's in alignment and a dance between the moon, the earth, and the sun. So the earth, the moon is in between the earth and the sun and casts a shadow on the earth. And that's a total solar eclipse when it completely blocks out blocks out the sun, and that's because it's close to Earth. And we go through as the moon goes around. We don't have one every month, but we do get them occasionally. We also have an annular eclipse. And an annular eclipse happens because the moon doesn't stay in a perfectly circular orbit. It sometimes is a little bit further away. So it doesn't completely block out the sun. So it leaves this ring of fire around the sun, like in the image that you're seeing here, in that annular eclipse. And this eclipse in Australia is a hybrid. So part of the path of totality is going to see totality. So you're going to completely block out the sun. Another part is going to see the actual ring of fire. And so that's why it's a hybrid. Based on the curvature of the earth and where you are on the path, you're either going to see the total or you're going to see the annular eclipse.
Okay, so eclipses are super cool events to see in the sky, but why do scientists care about eclipses, and what can we learn about them during these events?
Great question. So what happens during these events is that we can actually see with our own eyes the sun's corona, or hot outer atmosphere. And that's something that we, before the space age, we really couldn't do any other way. So we were able to study things that flow off of the sun, seeing this constant solar wind during these eclipses. We also did things like experiments in general relativity, and discovery of helium and other elements of the sun. So there's a lot of different things that you can do with eclipses.
So speaking of sun science, is there anything happening in Australia right now?
Actually, there is. There is a kite experiment that is going on during this eclipse. So it's a new platform for us to actually take data from. We've done things before in rockets or balloons or spacecraft, but this is now a kite. And you're shown here as a picture. This kite is 21 feet across, and it'll fly around 3,500 feet, and it will actually take a spectrometer, so it'll split the light up, is the instrument aboard, as it looks at the sun, and try to find that flow that I was talking about, that constant solar wind, and how that escapes the sun during this eclipse. And if it's successful, they'll hopefully fly it again in 2024 when the eclipse comes to North America.
That's so cool. Who knew flying a kite could be both fun and educational? I love it. So I mentioned at the top of the show that there will be opportunities for people to participate in sun science. Can you tell us a little bit about the Heliophysics Big Year, what it is, and how folks watching can get involved?
Definitely. The sun and all of us are in for a big year. Starting in October of 2023 with the annular eclipse that goes across the US and then down into Central and South America. Then going to the April 8th, 2024 total solar eclipse, and then finally ending the long big year, December 2024, when Parker Solar Probe goes to the closest approach to the sun, 94% of the way to the sun, to study that outer atmosphere that we're going to see here in a few minutes with this total eclipse. And so this year is a way that we can all belong in science and all belong to learning about the sun and all the different ways that the sun touches our lives. And the term big year actually is a birding term, a citizen science birding term that is studying as many species as possible of birds in one year. And what we're challenging folks to do is to study as many different things or relate to as many different things as they can about the sun. So can you see an annular eclipse? Can you see a total eclipse? What about aurora? What about seeing a solar flare go off? What about participating in a sport or another event that relates you to the sun?
And you mentioned citizen science, and citizen science is a big part of how folks can participate in the Heliophysics Big Year. A few specifics come to mind, like Eclipse Soundscapes is a citizen science project that allows you to participate in eclipse research by observing and collecting audio recordings during upcoming solar eclipses. You then take the data and analyze it and determine how eclipses may affect the ecosystem. And to learn more about that one, You go to eclipsesoundscapes.org. Another one is called the Nationwide Eclipse Ballooning Project. And this one will engage teams from a range of colleges and universities in an adventure in scientific ballooning. These teams will participate in scientific ballooning during the upcoming annular and total solar eclipses in 2023 and 2024 across the eclipse path. Student teams will use innovative balloon systems to conduct experiments. To learn more about this project, go to go.nasa.gov/NEBP. All right, thank you, Kelly. We'll come back to you in just a moment to answer some of the questions we have coming in. Don't forget to submit your questions using hashtag AskNASA or pop them in the comment box on the platform that you're watching. So as Kelly just mentioned, there's a big year of sun science ahead of us. Mark your calendars, because on October 14th, 2023, there will be an annular eclipse where the moon only blocks the center part of the sun and creates what looks like a ring of fire. And then on April 8th, 2024, millions of people across the US will have the chance to see a total solar eclipse. Where will you be? NASA has some new maps that could help you decide. Let's take a look. I am so excited for these upcoming eclipses. And truth be told, I've never seen a total or an annular eclipse. But for the annular eclipse coming up later this year, I know exactly where I'm going to be. I am going to be in Albuquerque, New Mexico, and I am so excited. So to take a closer look at the NASA eclipse maps in more detail, you can visit go.nasa.gov/US eclipse maps. Let's chat with a NASA expert who is in Australia right now for tonight's solar eclipse. We are joined by planetary scientist, Dr. Henry Throop. Thank you so much for being with us, Henry.
Hey, thanks for having me here.
So you're in Australia right now. Can you tell me exactly where you are?
So I'm in Exmouth, Australia, which is in the Ningaloo Peninsula in Western Australia. This is a really remote region of Australia. It's a long way from the closest city, Perth, closest large city, Perth, which is itself a very remote capital city. So there are thousands of people down here who have made the trek all the way out to Exmouth, waiting for this for totality, which is going to be coming up here in a little more than an hour. A little less than an hour.
That's so cool. That is so cool. I see a ton of equipment back there. Do you have anything with you, and what are you going to be doing?
So I have a solar telescope here myself. I'm going to be watching the sun as it disappears in H alpha, which is the wavelength where you see a lot of the activity of the sun. You see a lot of these features on the sun, both on the disk itself and off to the side. There are thousands of people here with their own telescopes, recording the sun, taking pictures of it in various ways. But most of the people here are not scientists. They are fans of the sun and are here for the excitement of being here at the eclipse. There are thousands of people who've been coming in all morning. Let me just give you a little tour of the site here. You can see. Going here, we are right next to the ocean here. A great place for seeing whale sharks. We're not going to see those today because everyone here is looking at the eclipse instead. And you can see all the thousands of people behind us there.
That is awesome. I am so jealous right now. That looks so awesome. Okay, we're going to let you go so you can go enjoy the eclipse and see it firsthand. Thank you so much for joining us. So here's a question. Since the moon orbits around Earth roughly once per month, how come we don't have 12 solar eclipses every year? So glad you asked. Here's why. All right, so many of you watching have questions about the sun and about eclipses. So let's get to some of those now. Remember, if you have questions, you can send them to us on social media using the hashtag AskNASA, or just drop them in the comment box from wherever you're watching us from. So now I'm back with sun expert Dr. Kelly Couric, and we're about 30 minutes away from totality. As a reminder, you are seeing real-time views of the eclipse in Australia, thanks to our friends at Time and Date. Kelly, let's tackle some of these questions that are coming in online. But first, I want to jump the line and ask a question myself. I am curious about how do you watch an annular eclipse and a solar eclipse safely?
That's a great question because really safety is our number one priority here. So for the annular eclipse, you will always have to use a pair of solar viewing glasses. These are not sunglasses. There are specific glasses that are made to a certain standard so that you can look at the sun through the annular eclipse. Or you could make an indirect viewing device, which means that your back is to the sun and that device is in front of you, whether that's a strainer, like a kitchen strainer, or even your hands. You can make a strainer this way and project the image of the crescent moon on or the ring of fire onto a wall or a floor, things like that. For the total solar eclipse, whenever the sun is only partially eclipsed, you must again have those glasses, the safe eclipse glasses, not sunglasses, to watch, or the indirect viewing method. And during totality, we want you to be able to look directly at that corona, directly at that sun's corona, the beautiful atmosphere that we study and that really flows out towards us and connects us to the sun. So that's how you safely view an annular and a total solar eclipse.
Okay, so I think I got it. So for an annular eclipse, eclipse glasses the entire time or indirect viewing method the entire time. And for a total solar eclipse, glasses, indirect viewing until totality, and then back to glasses, indirect viewing.
Exactly.
Got it.
You got it.
All right. Our first question from viewers online is from Mitsuhari Ida. And if I mispronounced that, please forgive me. On Twitter, she's asking, why are some eclipses longer than others?
That's a really good question. And it does have to do with how they line up. In the video that we saw just a little while ago, to get the eclipse, you have to have the moon and the sun and the earth in that direct straight line. And so sometimes it's just a little bit off in one direction. So you get some of the shadow, but not a lot. And based again, where that position actually is how long you get the eclipse. So about the longest we could ever get theoretically is around 7 minutes, 7 minutes of eclipse. Oh, wow. We're only going to get around a minute today in Australia, but we're very lucky to get about 4.5 minutes next year in 2024 wow. for the total eclipse.
Excellent. So looking at what we're seeing now, can you tell us what it is we're seeing, what we're looking at?
Yeah, so right now what we're looking at is the yellow or the white ball is the sun, and we have the black crescent on the bottom is actually the moon's shadow going across, or the moon's disk that you see blocking out the sun. So we've already made what is called first contact. So when the first looks like there's a little bite taken out of the sun by the moon, and we're moving through towards what will become the second contact, which meaning that that disk of the moon will touch the other side of the disk of the sun.
Wow, that's amazing. It's absolutely beautiful. All right, so let's head back to questions online. Prince Z on YouTube asks, how many times does this happen and how long does it last? And what impact does it have on our planet? So let's take that one at a time. How many times do total eclipses happen?
So there is a solar eclipse about every 18 months somewhere on the Earth, but the Earth is large and there's a lot of bodies of water, so sometimes it's over water and not land. So it's relatively common, every year and a half. But in one place, it averages around 375 to 400 years to get one in a specific place. So it's special to have it in your place, and you could probably find one if you flew somewhere in the world every 18 months.
Okay, and how long, you kind of answered this, how long they last, and if you want to elaborate on that, talking about like the different time frames that you mentioned before.
Yeah, definitely. So they can last anywhere from a few seconds or a minute to actually, up to 7 7 minutes would be the longest one, but that one's not going to happen for quite a long time. So really, about 4 minutes is 4.5 minutes we're going to see along the path in 2024.
And is there any impact of eclipses on the planet, on Earth?
Definitely. So we actually use them as a scientific study, both here and elsewhere. So when you're experiencing a total solar eclipse, and this is one of the things that, as beautiful as this image is, it can't quite capture, is it's a full body experience. So it becomes cooler. So there's a temperature change. It also gets darker. So animals that normally go to sleep at night go to sleep because they think it's nighttime, and then they wake up after the sun comes back up. So a rooster would crow, or crickets would chirp and stop chirping, and all of these things. So it does have an effect on the Earth, and we're actually using it also in 2023 and 2024 to study the ionosphere, or layer of the atmosphere, where we actually use for a lot of communications, and how that instant day-night shift. We're actually using it as a way to study that effect on Earth.
That's awesome. That's amazing that it does have this impact and that animals and nature responds. I think that is so cool. Okay, so next question. Tunisia Tucker on YouTube asks, these really seem rare. So when is the next hybrid eclipse?
Oh, that's a good question. I actually don't know when the next hybrid eclipse is. I'm going to have to look that up, and we'll have to find that and put that on the NASA website.
Do you know how rare they are?
They do tend to be a little bit more rare than the total or annular eclipse, because I think they have to happen at just a certain kind of geographic location. So they're a little more rare than the total or the annular.
Carolyn Craig has a great question that I also have. So, like, what equipment do we use to determine when an eclipse like this is going to happen, and how far in advance are these predictions made? How far in advance can we predict when an eclipse is going to happen?
That's a great question. And because we understand the orbital dynamics of the moon and the sun and the Earth, we can actually predict them out very far. There are maps of hundreds of years, if not thousands of years of data, because you can project where the sun, the Earth, and the moon will be. And so we rely on that predictability. And actually, in millions of years from now, the moon will be moving away so that it will not be able to actually do eclipses anymore. But that's really a long time away. But eventually the moon will not be able to cover. Yeah.
That is so
so we
fascinating.
Can put a long time.
Oh, wow. That's really cool. Mickey Manoia on YouTube asks a question you kind of already answered, but I'd love for you to elaborate on it. It's about like nature, and it's like, will the birds go silent, and do we know why? Like, what do they think is happening, since it's only for a short amount of time?
Right. So it's for a short amount of time, but you kind of have a somewhat normal lead-in to nighttime. So when you're experiencing a normal nighttime, the sky gradually gets dimmer. You start to see with a sunset maybe a pink or orange or beautiful colors, and so you know how to kind of get ready for bed, or get ready for it to be nighttime, um, and so it's not it's the light is eerie actually as you go into the solar eclipse. It's not quite the sunset, but it has some characteristics of the sunset. So I'm not an animal expert, but I would guess that they would just sense that it is um, the same kind of characteristics of nighttime. So, okay, let's get ready for bed. And then suddenly the sun comes back up and they're like, well, yes, that was the shortest nap ever.
I love that analogy. That is amazing. And it makes sense. Kevin Boaknight on Twitter asks, um, does it go completely dark during totality?
It gets very, very dark. And like I said, that the light is very eerie. When I saw my first total eclipse in South Carolina, it was definitely that like gray, dark around the eclipse, and then there was this eerie all around the horizon, like orangey light, much like a sunsetty type colors. So it was very eerie light, and it is significantly dark.
Oh, that's excellent. I'm so looking forward to it. It just sounds so artistic and creative and amazing. Oh, this is a good one. So Mike Meck on Facebook is asking for us to go in a little bit more detail on actual safety and eye safety on the glasses during the eclipses.
Great.
So like when you were talking about, so thinking about like in Australia, they're having it both a hybrid and a total eclipse, so annular and total. So can you talk about the differences and go through that again?
Right. So where our friend Henry was, they will have a total solar eclipse. So right now it's partial. The view that you're seeing from time and date is a partial eclipse. And so at that point in time, you must have your safety glasses on. Your eclipse glasses must be on, or again, indirect viewing method, one of those two things. So Henry right now should only be looking at this through safety glasses. And then once it becomes total, he can take them off and be able to look at the sun and look at the corona and see what it's doing. I'm very interested to see what we're going to see. And then once he knows that the moon is moving back and you're going to see more sunlight, that's when you have to put your glasses back on for the total. Now, if you were to go kind of a little bit further along the path of this eclipse, that is where you're going to see the annular eclipse. So they're actually not going to get an annular and a total in the same place. They'll get a total in this place, but then further along the path, it will become annular because the curvature of the Earth is then making the moon just that slight farther away. So it just, again, doesn't block out the whole entire sun. So those people who are further along the path of this eclipse who are getting the annular must keep their glasses on the entire time. So they will not be able to see the corona themselves.
Okay, excellent. Thank you for clarifying. Adam F on Twitter asks, how wide is the path of a total solar eclipse in general, would you say?
Right. In general, it could be normally around a couple 100 miles or 100 miles. So I think it's 150 in 2024. So yes, it's about that wide. It's not super wide, but it's a good distance.
Okay, next one. Sunrit Ghosh on YouTube asks, so this is a hybrid eclipse from Australia. So in Australia, it's a total eclipse. Where's the annular eclipse taking place? Do you know? Do you happen to know?
It is, I think, Papua New Guinea, like as you go up the path of totality. So I don't have a visual of the path right now, but yes, as you would go further up the path, you would see something again much more like you see on the right, the annular eclipse, that ring of fire.
Okay, so, and this is a really good question. So, Bray Kimberly on YouTube is asking, are there special cameras or lenses made for cameras to record solar eclipses?
There are, and this is another thing that we have to worry about with safety, or at least plan about for safety. And so we don't want to just use our glasses with this. So there are special filters for telescopes, binoculars, cameras that you can get. You can research and find appropriate filters to put in front of those at the entrance of the sun. So we don't want to use our glasses in this case. We want to use specific things designed for telescopes, phones, or binoculars.
Excellent. Okay, Mohammed Elma on YouTube asks a question about the geometry of eclipses. So, why is the sun and the moon, from our perspective, exactly the same size?
That's great. And it's a matter of distance and size. So, the moon is the right distance away and the right size because the sun is bigger, but it's so far away. So it's 93 million miles away versus the moon being much closer. So it's the same that I've been explaining it as the fact that when you put your hand right up in front of your face like this, you can black out almost and see everything. So the moon's just that close, where if you put it further away, you can see, around it and everything. So it's just the fact that the moon happens to be the right size and shape and then very close. And so that's why it's able to black out the whole huge sun.
It's all a matter of perspective, I hear you saying.
Yeah.
All right. Adriana Lazar on YouTube asks, why is the annular eclipse called a ring of fire? And then she also sends us love from Arizona and says, we rock.
Yay! I love Arizona too. So why they call it a ring of fire is that it looks like there is that orangey ring of fire around the moon, as this image shows. It looks like kind of something's on fire in a ring. So that's why it's called the ring of fire eclipse when it's an annular eclipse.
Right. So the sun is not actually on fire. There's no actual fire. It's just describing what it looks like, is what you're saying.
Exactly. The sun, yes, the sun is safe.
Excellent. SimCity on YouTube asks, if the moon moves on a horizontal plane, why are we watching the moon rise from the bottom up? So does the moon move on a horizontal plane?
Right. Okay. So the moon is inclined. So if the Earth goes on this plane, it's inclined. The moon is inclined. There we go. There's the graphics. Look at there. Is inclined as shown in this graphic. So it doesn't always hit. The shadows doesn't always hit the Earth, and that's again why we don't have 12 eclipses every year, because it's slightly off. And due to that geometry, that's why it doesn't do. So it's not in necessarily a horizontal plane, and that's again why we don't get eclipse every month.
All right, Chrissy Astromilly on Twitter asks, what observations are being done from space of the eclipse? And then anything from the other side of the moon or the moon shadow that you know of?
Oh, cool. All right, great. So for the assets that we have in space that are watching the sun, they aren't necessarily in the path of this eclipse, right? They don't necessarily live right over Australia per se. But we do make instruments that simulate an eclipse. So things called coronagraphs. So we basically make a false moon that kind of looks like a thumb that goes up in front of the camera and blocks out the center of the sun, so that then we can go and see the corona that's coming off of it. So we do make space-based eclipse observations, but they're not the natural eclipse observations. They end up being manufactured. We do sometimes in certain telescopes like Hinode, and I think SDO as well, Solar Dynamics Observatory, are able to get eclipses in their orbit as well, but they don't normally coincide with the ones that we're talking about here. Because they're on a different orbit, they have a different trajectory that line up the spacecraft and the moon and the sun.
Excellent. Our team behind the scenes got us an answer to the question about why today's annular eclipse is visible. Where today's total solar eclipse is visible. So the total eclipse is visible in Australia and Southeast Asia. The annular eclipse is visible over the Pacific and Indian Oceans, and a partial eclipse is visible from Australia, Southeast Asia, and Antarctica. So there's that. Thank you, behind the scenes team. Love it. Rebecca Gergens says she is watching the live solar eclipse with her class in Macau. And if it is daytime in Australia, why does the telescope feed look like it's nighttime? So why is it all dark? Why is it black?
Well, yeah, that's interesting. So they are looking, I think it has to do with the filter of the telescope. They're filtering out the light so that they can, I think this is the H alpha feed, which really focuses on a specific part of the light. So you get that heat from the sun, because I'm starting to see a prominence appear in the lower left-hand corner. So just past there, their little thing that's kind of shooting out, a prominence there. That kind of indicates that that's the wavelength or the type of warmth of light that we're looking at. So that's why it probably looks dark, because nothing else out there is that warm. But yes, it is daytime in Australia. But as the sun's covering up more and more, it will, at least in Exmouth, will become darker and darker, and again experience a false night for about a minute.
Excellent. How you doing? Are we killing you with the questions? They are coming. They are
These
great.
These are great questions.
All right, I have a really good one from Angel Shinari. She asks, next year, totality will be in Mexico. So I'm assuming it's a total solar eclipse. And she's wondering if you know how long will totality last then? Any ideas on that one?
So it's around 4.5 minutes. And there are great resources online that you can find your city and state and find the exact timing for that location. And that's actually another important part of planning your eclipse viewing, is to go to those trusted sites and find the list of the times that both the length of totality, so that you can enjoy that corona and soak up all of that beautiful solar wind and that and all the magnetic fields that are moving things around. And that you'll be safe, that you'll be able to know when you need to put your glasses on, and to plan to make sure to be there well ahead of time so that you don't miss it.
And will NASA have resources that kind of help people find places and times and that kind of information?
Definitely, there are some resources that will help with things like the map. We'll show you where there is the path along the path of totality, and what cities and states will experience totality. And actually, the entire contiguous U.S. will have a partial eclipse that day. So even if you're not part of the line that goes from Mexico to Texas, up through Oklahoma, Arkansas, Missouri, Illinois, Indiana, Ohio, Pennsylvania, New York, Vermont, New Hampshire, and out through Maine, and then Nova Scotia, in Canada, all of those places. You'll get a total solar eclipse, but the entire continental United States will get some type of partial eclipse as well. And then the other side of that, on the left-hand side, is the annular eclipse that will happen in 23.
That is so cool. And it kind of brings us back to like the heliophysics big year, like the sun touches everything. And in the US, like that is such a unifying and just a beautiful moment when everybody will get at least some portion of an eclipse. That's really cool. Before we pop to the next question, we want to thank Time and Date for this amazing feed that we're watching. And we're watching it live. We're watching the magic happen live. I'm so excited. Let's go to a next one. Morts730 on Twitter asks, what changes the duration of totality? So what makes it different?
Right. Again, it's all about geometry. So it's all about where your place in space. We all belong here, and the place in space does matter. So depending on exactly in the orbit of the Earth and the Sun and the Moon and how they line up, is how long you will get totality for. In this case, how it lines up, and because it's at a place where the moon shadow is moving very quickly, it only lasts for around a minute. When you're closer to the equators, it takes a little longer to move across that land, so it goes a little bit slower. You can get a little bit longer durations, and then again, it's all about that lineup between the Earth, the Moon in the center, and the Sun. And so as it goes around, it will create, different lengths of time in the eclipse.
Oh, that makes sense. Yeah, that's a great explanation. Nat A on YouTube asks about eye safety. So what happens, or what could potentially happen, if we look directly at an eclipse or look directly at the sun?
Right. So looking directly at the sun, which you should never do, would cause the back of your eye to burn in the image of the sun. And so you would have a blind spot in the area where you had viewed the sun. So it is not advised to do this. So make sure that you have your safety glasses or an indirect viewing method if you don't have safety glasses, in order to make sure that you can safely do this and safely see afterwards.
Yes. So the takeaway is be safe. Got it. Love that. The Plastic Effect on YouTube asks a really good question. So are lunar eclipses or solar eclipses more common? Is one more common than the other?
Oh, that's a good question. Wow, I've never thought of that. I was like, oh, you just put that on me, because a lunar eclipse happens when the Earth is blocking the sun from the moon, and so that is why you're getting that darkness or that eclipse. Is it more common? I think it is, but my brain is not functioning. Maybe we need some behind the scenes. Some phone a friend.
I love it. The Plastic Effect. You may have stumped NASA scientist. That just goes to show you, like, we don't know everything. I think these are great questions. We have Kelly on the spot. She doesn't have any of these answers. She's answering you're doing an amazing job, my friend.
I mean, really, that's what a scientist is. It's about, figuring out how to do it and finding the right source of information, right? So it's not necessary that I know every fact and everything about, the sun. It's about, I know how to examine the information and say, oh, hey, like this person might know it better, or and then is that reasonable, right? If they suddenly told me like, well, the moon's made out of, blah, 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 I'm like, no, that's not right. I need to know, approximately what it is. But again, I don't necessarily know everything.
Yeah, and we specialize, right? Like as a scientist, you're specializing in heliophysics, and then we have people that specialize in planetary science or lunar science, and so it makes sense. I'm just messing with you. I'm just joshing with you. All
Okay.
right. Scott is asking, why does the moon change locations on screen when we see different time and date telescope feeds?
I think that that is just a orientation of the telescopes.
Yeah.
Because yeah, it might drift to like one side of the feed, one side of the picture or the other, and that's just alignment of the telescope. It takes a lot of setup to learn how to do this type of imagery as well. They're doing amazing at time and date, and they have done amazing for forever. So, but it takes a lot to get it to look this good. So that's actually why I tell people your first eclipse, let the experts do it and just experience it, because you can. It's a great hobby to figure out how to how to do this, or and how to line up the telescopes and do that. But it's a lot of work, and so maybe the first one, just experience it.
Yeah, yeah. I am looking forward to my first one. No cameras, no anything. It's just going to be me and watching nature do its thing. I love it. Okay, we have another kind of moon question for you. Aaron Equus on Twitch asks, so there's a lot of talk about the sun during the solar eclipse, of course. Are there any unique properties of the moon that are only visible during an eclipse that you know of?
That's a good question. Um, the moon is rocky and not quite as smooth and kind of it looks like a beautiful ball when it's full from the earth, but it actually has craters and valleys, so peaks and valleys, and you can see some of those, and that's actually what we'll see coming up here with the Bailey's beads, is actually the last bits of the fact that it's not perfectly smooth. We're seeing little bits of sunlight still kind of escape until it completely covers the face of the sun. So as you're seeing in the feed right, or in the image right now, is you'll see those little beads, and those are actually telling us about the peaks and valleys on the moon.
Excellent. Okay, so we have a really good question from Heather Jarvis. And the question is it happening or almost over? And what time is totality? So, what are we seeing
So
here?
it is happening. So we have most of the disk covered right now, and so the upper left is the moon. That dark circle or semicircle is cutting out the little crescent sun that we're seeing, and the prominence is still there on the left hand side. And so what is happening, and I think we're around 10 minutes, I think, from no 15 minutes from totality. And so then we'll see those Bailey beads that we just talked about. Diamond ring is the last one that comes out, because it looks like there's a great big diamond on the sun. And then that'll go off, and then we will see totality. And that's where we would take off our eclipse glasses if we were there, and kind of bask in seeing the corona and experiencing the whole thing. And then after that minute's over, we would put on our glasses, and we will then go backwards and see the diamond ring, the Bailey's beads, and then back to this partial eclipse.
So, you kind of talked about this before, but Kaz on YouTube is asking, is it possible to never have an eclipse during a year?
Since they happen about every 18 months, it would be possible to not have one during a year.
Yeah. And I'm assuming that just meant solar eclipses
Yes.
that Kaz was asking about. All right.
Mhm.
Very Pezzy on YouTube asks, is it possible to see the eclipse using a telescope from home?
That's a good question. So really, you need to be in the path of totality. or a path of path of the eclipse in general. So either a partial eclipse or a total eclipse. So it somewhat depends on where you live. Again, if you're in the US, you will see one in 2024 or 2023. So hopefully, yes. And then if somewhere else, we can find resources online to see when the next eclipse is going to be in your area.
Excellent. Our folks working in the background, you guys are geniuses. So for the question asking if lunar or solar eclipses are more common, we have a little bit more information for you. Lunar eclipses and solar eclipses are about equally common. They usually happen in pairs. So a lunar eclipse will usually happen 2 weeks before or 2 weeks after a solar eclipse. However, more of the Earth will be able to see a total lunar eclipse than a total solar eclipse. So they may seem more common in one given location. So thanks for that.
Yeah, that's great, because I think that's what I was thinking, is it's more common to be like, oh yeah, you can see a lunar eclipse, than a solar eclipse is a much more narrow path because the moon's smaller. Yes. Okay, great.
Excellent. Yeah, that was
Thanks.
a really good answer. Thanks for the clarity on that. Willie D on YouTube asks, what kind of gravitational pull does this kind of event do to the life on Earth with celestial body alignments? Are there animals and plants that react to this event? Thanks.
Okay. Well, that's great. So animals and plants do respond to this event in general. Again, from what I understand, is much more from the actual visual or sensory of the darkness that they sense, rather than maybe direct gravitational pull. But maybe that's a study that you should propose. That what's the effect on animals for gravity? I think it's my sense is that it's more from a visual sense than a gravitational sense, that there's an effect on animals.
Gotcha. Okay, that makes sense. Susan Stalker asks, do solar flares interfere with technology here on Earth? And is there cause for concern? That's a really good one.
That's a really good question. Yes, solar flares do potentially cause issues with our technology here on Earth and all of our space assets. And so we are, at NASA, as well as in partnership with many different folks in commercial, as well as all with government, NOAA, NASA, NSF, all of the folks are working on this. It's a term called space weather. It's the effect that the sun has on the Earth and the entire environment, the entire interplanetary environment. So we are looking to mitigate those things, things like potential power outages or inducing huge currents in the Earth, things like that. We are looking into that and making sure that those solar flares don't get the best of our technology.
Yeah, and that's a big part of the heliophysics big year, right? So like at NASA, the heliophysics has a fleet of missions that are working to study the phenomena of space weather and the sun's impact, throughout our universe. Particularly, do you want to talk a little bit about Parker Solar Probe, which has touched the sun?
Yes, so Parker Solar Probe, a little near and dear to my heart, is the spacecraft that has gone in and actually touched this corona that we have seen. And it is a spacecraft that goes in and looks at the particles coming off of the sun, both through imaging as well as scooping some up in some of the detectors and studying the magnetic fields of the sun. So that mission has successfully touched that corona and is continuing to study it and to, again, help us understand that space weather.
Excellent. Yeah. Looking at this, we're getting closer. We're getting closer. I'm so excited. It's happening.
I know. It looks like a great big smile. It's a great big smile right now. The sun's kind of smiling.
Okay, back to the question. So we have two related questions. David Gray on YouTube asks, what is the expected temperature drop during a total solar eclipse? And Raymond DeMay on YouTube is asking, is there a measurable temperature drop? So are people going to be able to feel a difference?
You can definitely feel a difference. It can be a couple degrees to tens of degrees. So like for instance, my last solar eclipse, I had to put on a down jacket. I was in a short sleeved polo and had to put on a down jacket. I'm also cold, so, but it was definitely noticeable that folks were putting on jackets. And so it is a measurable temperature, and that is part of a citizen science project, is to actually measure the temperature as you're going, as this is going along, especially with animal reactions, is to figure out what they're actually reacting to.
Here's a really good one, kind of based on something you said earlier. Forrest Walker 111 on YouTube asks, if a flare were to happen right now, would it be visible? Would we be able to see it during during the eclipse that we're watching?
So if we were to be able to see a visible light flare when the eclipse was happening, that would be a big event. That would be related to, so for instance, one of the most powerful events that we kind of have recorded is the 1859 Carrington event, where telegraph lines at the times caught on fire and were able to work without batteries for days based on the energy that was imparted from that flare to the earth.
Wow.
So if we were to see an actual flare in the visible light, that is what was seen associated with that as well. So that's a big storm. So it'd be super cool, yet at the same time it would be very interesting to see what would go on. Most of the flares we look at right now are done in the extreme ultraviolet, and that is how we normally see them, which is unfortunately something we can't see with our own eyes.
So one thing you've mentioned a couple of times, and people are asking questions about it, is a prominence. So what is a prominence? Is that a flare that we are seeing on the left side of the sun, or what is a prominence? What are we seeing?
Good question. Yeah. So a prominence is a protrusion of some of the gas of the sun along a magnetic field line. So the sun is a magnetic star, and the background image you're actually seeing has kind of those twisty magnetic fields and the gas or the plasma following those. And that's what a prominence is. It's a sticking out of one of those magnetic fields, and then the gas and plasma sticking with that magnetic field line and protruding. And so it can be a precursor to a flare. It could be part of a coronal mass ejection. It could be ejected from the sun as a mass that comes through the solar system. It's equivalent to 80 million school buses in mass hurling at us at 1 million miles an hour when a coronal mass ejection goes off, and a prominence can be part of that. So that's why it's just interesting. It is an active part, and there was some active regions rotating off the disk, and I think it was just about that area. So I was interested to see what we would see once we got to totality. So, and we're getting close. We're getting really close now.
I know, it's so close. All right. Shariah on Twitter asks, are we able to see sunspots during a solar eclipse?
We are actually able to see sunspots most days, so which is great. So when the sun leaves again, or sorry, when the moon leaves again, and we can see the sun, there were some darker features on the sun, little spots, and so you are able to see sunspots in the visible light. And even with your eclipse glasses, you should be able to see, go out and see when there are large sunspots on the sun.
Okay, we've got another question on safety. Dobby330 on Twitter asks, is there any part during an eclipse that is safe to directly look at the sun without glasses?
Yes, and we are almost there. So when that moon is totally covering the disk of the sun, it is safe to take off your glasses and to see the solar corona. Now, again, we have to really make sure that we're on the path and we know that there is totality and that we can't see anything. And one good test is if you have your glasses on and you're looking at the sun and there is nothing coming through those glasses, that is when you can take it, then you can take it off. If you see the littlest light in that glasses, because they're really dark, you're not going to see normal lights. but you will see the sun through them. But when you don't, that's a sign that you can take off your glasses.
We're close. Let's do another one. Gabrielle Codina on YouTube asks, is it possible to encounter an eclipse and northern lights at the same time?
Ooh, that would be like a really great thing to do. So we would just need to have an eclipse over. You normally see aurora in the northern or most southern latitudes, northern or southern lights. So if we were to have an eclipse that passed through, say, Alaska or Greenland or Iceland, you might be able to catch both the eclipse and the aurora.
We're close. All right, let's see if we can squeeze another one in. This is a really good one. Shades McCoy on Twitch is asking about, have we discovered any planets that experience total eclipses or eclipses like Earth does? It feels pretty rare.
It does. And actually, my colleague Michael said this the other day, that realize that this is the only place in the solar system that this happens. Like, how special is that we get to be here and have a moon that blocks out the sun? Like, it's not something that's done every day or any place else that we know of. So this is very, very amazing. And we do use eclipse-like things to measure, to actually find exoplanets or other planets around other stars, because as they pass by, they weaken the light from the star, and we use that to actually sense that they're there. So we use an eclipse-like scenario, but we don't know of really any other eclipses.
Interesting. All right. So it looks like we're getting like really close to totality. Let's take a closer look at the feeds coming in from Australia. Kelly, do you want to tell us what we're looking at and kind of talk us through this?
Yes, definitely. Awesome. So we're getting really close. So the dark upper left-hand side, you see the moon, and then that little sliver is still the sun, and then the prominence, again, that little stick out of magnetic field and plasma is at the left. It looks like a little jet maybe coming off of the sun. And as we're getting closer, again, we're trying to see those Bailey's beads, which tells us a little bit of the surface of the moon and how it's peaks and valleys. It's not a perfect polished sphere. It has a history, and we're going to see that shown through the Bailey's beads, and then eventually just go to one diamond ring, and then we will go into totality. So again, we're getting real close, about 2 minutes.
Wow. And you can still see the prominence.
You can see the prominence more and more. And I'm actually seeing a little bit of something also almost directly across from it. There's a kind of a band of activity that happens as these things form. And so it's kind of in that same band. So I think of it as almost directly horizontal, but we'll see as we get closer if that comes out at all, and could see a little bit better. No, we're really getting dark. And so if we're in Australia, it's probably, again, dropped in temperature a little on that beach that we saw Henry was at. And again, any animals might just start to think that it's nighttime. The air or the light will actually get really kind of, it just feels eerie. And it's like your brain knows that something's just not quite right. Like, I'm not sure about this. Where did the sun go, and why is it in kind of a different color? And it's getting really, really close, and it's exciting to experience this live with y'all.
Yeah, and we're still glasses on, right?
We are still glasses on at this point in time. You will still be able to see that thin. Yeah. And so we're almost there. Oh, and now it has gone dark. Oh, that's still too bright. We probably should still have our glasses on. But those are the Bailey's beads. And we are going towards those beads. diamond ring. And there we go. There is your total solar eclipse. So glasses off at this point in time, experiencing this beautiful corona. So that prominence is out there. You see that. You also see on the other side, almost like helmets or triangular shaped flows. So the solar wind is flowing out. And so we're really witnessing that corona there. And as they adjust things, wow, there's just all sorts of structure. So it's not a simple thing, right? It's a very complicated, dynamic, always churning, always moving, always evolving. And you see so much structure out. And this is what hopefully that kite is recording right now, is all of these different prominences, and you almost see loops sometimes. And then again, things that look like they flow out of the picture. That's the solar wind, and that's what connects with our planet. And now we're actually getting the Bailey's beads back, so this would be glasses on. Again, it was a very short but amazing experience. And again, we're going to have around 4.5 minutes in places in the U.S. In 2024, but that was beautiful. So yeah, so the Bailey's beads are coming back. We're coming back now into what is more of some more beads coming back. And you can still see a little bit of the corona, but again, we would have our glasses on at this point in time because this is the safest, this or your glasses are the safest way to view the solar eclipse.
Wow, this is just phenomenal. Absolutely spectacular.
It is amazing.
Wow. How many eclipses have you seen?
So I have seen 2 total eclipses in person.
Wow.
Yeah, and each one is magical, and there is just something about experiencing it that is surreal. Oh wow. Yeah, so there's the prominence and all of the other type of mass that's just kind of hanging out there and playing on the loops, the magnetic loops of the sun. And yeah, it's beautiful.
That is absolutely phenomenal.
Yes, and this activity kind of picks up as we go towards solar max. And so with predictions right now, solar max is somewhere between 2024 and 2025. So we could have a very active and really structured and a lot of different things on the sun as we have our total eclipse in 24 and our annular eclipse in 23.
So can you talk us through that a little bit? So you're talking about solar max. So the sun has cycles, the solar cycles. What's the difference, and what does solar max mean?
Yes, yeah. So the sun has cycles in its magnetic energy. What happens is basically the magnetic fields get twisted, and then suddenly they have to just break and relax. And so the minimum is when they're relaxed, and the maximum is as they are getting more and more twisted and more energy to blow off the steam through coronal mass ejections. Those, again, 80 million school buses racing towards us at millions of miles an hour, or the solar flares or the energetic particles that the sun gives off. And so this cycle, that going from that really relaxed magnetic field to really tense, it takes 11 years to complete. So you end up going around 5 to 6 years to a maximum, and then back to a minimum, and back to a maximum again. And we're headed towards a maximum in 2024, 2025. And so that's, again, we're going to have a lot more activity, more flares, more coronal mass ejections, and those energetic particles.
Well, okay, so let's keep watching as we take a few more questions. Here's a really good one. Aaron Polito on YouTube asks, what useful data does NASA get, and what do they do with it from observing eclipses?
That's a great question. And we take all sorts of different data during eclipses. There will be an announcement soon of things that we're specifically doing for the 24. But for instance, for the kite that is flying in Australia today, there will be a spectrometer. So there'll be data from that, and that will all have to go into an archive for NASA and to make sure that's open and available to folks. So any of the things, any of the data that is collected from a NASA source will then be available to use for anyone shortly after it is collected.
Oh, wow. Okay. And I've heard that eclipses provide kind of like a perfect scientific environment for taking measurements if we're trying to do certain types of measurements. Why is that?
It is a really great environment in terms of we don't normally get to turn off the sun on things regularly. We don't get to snap our fingers and just turn night to day or day to night. So for instance, in 23 and 24, we will launch rockets into the eclipse and be able to study our ionosphere, which is a layer of our atmosphere where a lot of our communication signals go through. And if that gets disturbed from a day to night transition, we get to be able to study it very easily during an eclipse, because that's again like a very specific time where we know it's going to happen and we know it's and we can study those effects, and that's a very known time to do these things. So it's great to have as an experimental laboratory for us.
Yeah, that's so cool. And I love that. Like we don't get to turn off the sun. That is so true. Okay, so an Arctic Floof on YouTube asks, once totality has happened, how long will it take for the sun and the moon to be back to their normal, and I'm using air quotes, positions?
Right. So this will take about another hour or two to move the moon off of the sun, or the what will then be look like two separate things again.
Okay. Road Call Life on Twitter is asking, does totality last longer in the middle of the path of totality than along the edge of the path of totality, or is it the same everywhere? So like, how does that work? How does
Yes, that's a great question.
Yeah.
Yeah, and so in the very middle of the track is where it will be longest, and then it will be shortest on the outside of the track. So when we were looking at the map earlier, the very center is where you're going to get the longest totality, the very center line. And then as it goes out, you will get kind of less and less time in totality. And then once you're out of the track completely, that's when you get a partial eclipse, like a 90% or 99% eclipse.
Excellent. Well, Kelly, that's all the time we have. Thank you so much for joining us today.
My pleasure. Anytime. I'll watch an eclipse anytime with you, Denise.
It's a date. All right. You can keep watching the remainder of the solar eclipse right here on NASA TV or wherever you're watching the stream from today. If you want to learn more about eclipses, visit solarsystem.nasa.gov/eclipses. And you can also follow NASA Sun on Facebook and Twitter to stay updated on the upcoming eclipse events and the latest sun science. Thank you all so much for joining us. We'll see you next time.
The Heliophysics Big Year is a global celebration of solar science and the sun's influence on Earth and throughout the solar system, and we want you to be a part of it. We challenge you to participate in as many sun science activities as possible, beginning with the annular eclipse in 2023 and ending with Parker Solar Probe's closest approach to the sun in December 2024. Space is increasingly part of the human domain. By studying the sun's influence in space and its interactions with planets, we learn how to better protect astronauts and robotic missions from space weather, and to develop technology that protects the very infrastructure we rely on here on Earth, such as power grids and GPS signals. NASA's heliophysics division studies the sun's influence on everything in our solar system, from the very core of the sun to the very edge where the sun's atmosphere meets interstellar space. We have 20 heliophysics missions that are operational and 14 more under development. The Heliophysics Big Year will highlight the work that we're doing to understand our star and to mitigate the effects of space weather. The Big Year is a concept that originated with citizen scientists in the birdwatching community. During their big year, birders attempt to observe and study as many species as possible during a calendar year, and we are challenging you to do the same with our sun. During the Heliophysics Big Year, you will have the opportunity to participate in many solar science events, like watching solar eclipses, experiencing an aurora, participating in citizen science projects, and lots of other fun sun-related activities. So please be sure to look out for opportunities to be part of our Heliophysics Big Year.
Imagine you are on the moon. Your job for the next 8 hours will be exploring, traversing up and down lunar hills, sampling rocks, and setting up equipment. Temperatures can reach a blistering 250 degrees Fahrenheit. Luckily, you have a portable life support system, a backpack that provides oxygen, water,